video, we are going to explain about a project titled Enhancement of Low Resolution Remote Sensing Images using ANN. Remote sensing assumes a pivotal role in amassing the vital insights about Earth's surface through sensor-equipped satellites and the platforms. Yet the efficacy of the low-resolution remote sensing imagery is often compromised by its inherent lack of precision and the intricate details, potentially undermining the data accuracy and the utility. In response, the scientific community has turned its attention to the artificial neural networks as a prospective remedy for enhancing these lower resolution images. ANN have showcased the remarkable process in image processing domain, sparking the interest and the application within remote sensing. By leveraging the ANN, there is a potential to uplift the image quality, fostering a conducive environment for the refined analysis and bolstering the efficacy of remote sensing data across the diverse fields such as environment monitoring, disaster management, and the urban planning. The central aim of this research is to delve into a formulate an image refinement technique using the ANN tailored for the low resolution remote sensing visual. A key emphasis lies in exploring the prowess of the ANN, notably the CNN, in extracting and assimilating the pertinent attribute from the input image. Through the integration of these neural architecture paradigms, the objective is to highlight in both the resolution and the visual fidelity of the remote sensing depictions, all the while safeguarding the essential spatial intricacies. The overarching aspiration is to furnish a more precise and intricate portrayal of the Earth's expanse, thereby elevating the informed decision making across the diverse realms like environmental surveillance, disaster evaluation, and the urban development. By harnessing the capability of the ANN, this research aspired to enhance the utility and the accuracy of the remote sensing imagery, addressing the real-world challenge with the sophisticated computational solution. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this step involves importing the essential Python libraries, including the image processing library like OpenCV and the machine learning framework like TensorFlow for building the ANN. And the second one is exploring the dataset. The dataset containing the low resolution remote sensing images is loaded and explored to understand its dimension, data types, and other attributes. And the third one is image processing. Image processing tasks follow address the potential issues like noise reduction, contrast enhancement, and the brightness adjustment. This step aims to improve the quality of image before ANN-based enhancement. And the next step is processing the data and the extraction from the image. In this stage, data extraction from the image is performed. This involves isolating the feature of the interest, such as landmark or the object, to create the focused input data for the ANN model. And the next step is splitting the data into the train and the test set. The dataset is divided into the training and the testing subset. The partition ensures the model performance is evaluated on unseen data, helping the gauge its generalization capability. And the next one is building the model. Here, two models are developed to enhance the low resolution remote sensing image. The first one is CNN, stands for Convolutional Neural Network, or the integral for enhancing the low resolution remote sensing image. Utilizing the convolutional and pooling layer, CNN automatically extracts the spatial features like edges and textures. This specialized architecture captures the local relationship, enhancing the image quality by revealing the intricate details. CNN efficacy lies in the ability to learn the hierarchical representation and making them well suited for the image-related tasks. And the second one is ANN. It stands for Artificial Neural Network, also contribute to enhancing the low-resolution remote sensing images. Unlike CNN, ANN have more general architecture with the interconnected layer. While not as specialized, ANN can still learn the complex relationship within the data, making them adaptable for the image improvement. Training ANN involves teaching them to recognize the pattern that bridges low resolution input and the high resolution counterpart, enriching the image quality through the learned association. And the next step is user gives the input. User provides an input image by using the class as an web interface. And the next step is upload the selected image and forward to processing. The user uploaded image is pre-processed to align with the model input format, such as resizing it to match the expected dimension. And the next one is calculating the MSE and PSNR value. The mean square error and the peak signal to noise ratio values are computed to quantify the quality improvement achieved by the enhancement model. These metrics measure the difference between enhanced image and the original low resolution image. And the last one is final outcome is displayed. The enhanced image along with the calculated MSE and the PSNR value is displayed to the user with the help of the Flask as a web interface. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it, the dataset folder containing of images within it, and the images folder containing of various images that will be used to test the performance of the model. And the RCCNS7 contains a folder containing of the various images within it, and the static folder containing of the CSS images JavaScript assets within it, and the template folder containing of HTML documents, a typically include of result sign-in sign-up pages within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. Pasting this link and then click on the enter button. After this, we get a page containing of some information and the title of the project. And then click on the login button. Here it will redirect to the login page containing of username and password, and we need to give the details of those and then click on the login button. Here it will redirect it to this index page containing of the some title and of select image button. By clicking on the select image button, here we redirect it to this folder containing of various images within it. I am selecting one and then click on the open button. And here we need to click on the see the result button. This is the input image, and by clicking on the see the result button, we get the enhanced image with the given input image width of the mean square error true. And here this is the input image and this is the enhanced image, where we can see the clarity and the enhancedness in this high resolution image, and the MSC value is of 53.2089 for the input and the PSNR value is of 30.87 for the input given. And by clicking on the download enhanced image, we'll be back to this enhanced image. In this way, we can enhance the quality of the image by using CNN and ANN. In conclusion, the enhancement of the low resolution remote sensing images using ANN, particularly CNN, have proven to be a promising approach. Through our research and experiments, we have demonstrated the potential of ANN to effectively increase the resolution and improve the visual quality of remote sensing imagery. By learning the spatial pattern and the feature from the input data, the CNN can generate the enhanced image with finer details, making them more suitable for the various downstream applications. The successful application of ANN-based image enhancement technique open up the new possibility for the remote sensing and its diverse application. Improved image quality, more accurate and reliable analysis, leading to the enhanced data-driven decision making in the fields like environmental monitoring, agriculture, urban planning, and the disaster management.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.